October 14th, 1943. 30,000 feet above Schweinfurt, Germany. 291 American B-17 flying fortresses are under attack. Wave after wave of German fighters, Bf-109s and Fw-190s, tear through the formation. The bombers' .50 caliber guns hammer back, but it's not enough. The P-47 Thunderbolt escorts turned back 20 minutes ago, out of fuel, out of range. The bombers are alone, 400 miles deep into Germany, and the Luftwaffe knows it. By the time the formation limps back to England, 60 bombers are gone, 600 men dead or captured. Another 17 aircraft so badly damaged they'll never fly again. It's the worst single-day loss in 8th Air Force history. They call it Black Thursday. General Ira Eaker, commander of the 8th Air Force, writes a memo to Washington. The losses are unsustainable. Without long-range fighter escorts, daylight bombing over Germany is impossible. The entire strategic bombing campaign is in jeopardy. The solution already exists. The P-51 Mustang, the fastest, most maneuverable fighter in the sky, but it has one fatal flaw. Range. The P-51 can fly 400 miles and back. Berlin is 600 miles from England. The deepest targets in Germany are 700 miles. The Mustang can't reach them. But one engineer at North American Aviation has an idea the Army Air Forces says is impossible. External drop tanks, disposable fuel tanks mounted under the wings, tanks that can extend the Mustang's range to over 1,000 miles, tanks that can be jettisoned when empty or when combat starts. The brass says it can't be done. The weight will make the aircraft unflyable. The aerodynamics won't work. The fuel feed system is too complex. But to understand why drop tanks mattered, you have to understand the strategic bombing campaign and why it was failing in 1943. The theory was simple. American B-17 and B-24 bombers, flying in tight formations and bristling with 50 caliber machine guns, could defend themselves against enemy fighters. They would fly deep into Germany in daylight, bomb factories and oil refineries with precision, and fly home. No need for fighter escorts. The theory was wrong. German fighters, particularly the Bf-109G and Fw-190A, developed tactics specifically to break up bomber formations. Head-on attacks from 12 o'clock high, where the bombers had the fewest guns. Attacks from below, where the belly was vulnerable. Rocket attacks from outside 50 caliber range, the bombers fought back. Gunners shot down hundreds of German fighters. But the loss rate was catastrophic. In the summer and fall of 1943, the 8th Air Force was losing 5% to 10% of its aircraft on every deep penetration mission. Do the math. If you lose 5% per mission, and crews fly 25 missions to complete a tour, the survival rate is less than 30%. Most bomber crews didn't make it home. The solution was obvious: fighter escorts. Fighters that could stay with the bombers all the way to the target and back, engaging German fighters before they could attack the formations. But in 1943, no Allied fighter had the range. The P-47 Thunderbolt, the primary escort fighter, could fly about 425 miles on internal fuel. That meant it could escort bombers to the German border, then had to turn back. Any target deeper than that, the bombers were on their own. The P-38 Lightning had slightly better range, around 450 miles, but it was complex, expensive, and its twin engines made it vulnerable. One engine hit, and you're flying home on one engine if you're lucky. The British Spitfire, arguably the best fighter in the world in 1940, had even shorter range, about 400 miles. It was a defensive fighter designed to intercept bombers over England, not escort bombers over Germany. And then there was the P-51 Mustang. The Mustang was designed in 1940 by North American Aviation for the British Royal Air Force. The British needed fighters desperately, and North American designed and built the prototype in 117 days. It was fast, maneuverable, and relatively cheap to produce. But it had problems. The original Allison engine didn't perform well at high altitude. Above 15,000 feet, it lost power. Since most combat in Europe happened above 20,000 feet, the early Mustangs were relegated to low-level reconnaissance and ground attack. Then, in 1942, someone had an idea. What if you put a Rolls-Royce Merlin engine in the Mustang? The Merlin was the engine that powered the Spitfire. It had a two-stage supercharger that maintained power at high altitude. Packard was already building Merlins under license in the United States for the P-40 and other aircraft. North American built 5 prototypes with Packard Merlin engines. The result was extraordinary. The P-51B, as it was designated, was 50 mph faster than the P-47. It could outturn the Bf-109. It could outclimb the FW-190. At high altitude, it was the best fighter in the sky. But it still had one problem: range. On internal fuel, 180 gallons in fuselage tanks, the P-51B could fly about 400 miles and return. That was better than the Spitfire, but not much better than the P-47. It still couldn't reach Berlin. The solution, in theory, was simple: add more fuel. But where? The fuselage was already packed. Engine, cockpit, guns, ammunition, radios, oxygen system. There was no room for additional internal tanks without a major redesign, which would take months or years. The wings were full of fuel tanks, guns, and ammunition. The landing gear retracted into the wings. No room there either. The only option was external tanks. Tanks mounted under the wings or fuselage that could carry extra fuel, then be dropped when empty or when combat started. External drop tanks weren't a new idea. The Japanese had used them on the Zero since 1940. German fighters used them. Even some American aircraft had experimented with them. But there were problems. Big problems. First, weight. A full drop tank could weigh 600 to 800 pounds. 2 tanks, one under each wing, added 200 to 600 pounds to the aircraft. That's a massive weight increase for a fighter that normally weighed 9,000 pounds fully loaded. The extra weight affected everything. Takeoff distance increased, climb rate decreased, maneuverability suffered. If a Mustang with full drop tanks encountered a German fighter, it would be at a severe disadvantage until it could jettison the tanks. Second, aerodynamics. Drop tanks create. The engineer's name was Edgar Schmude, though the paper tank idea came from the broader engineering team at North American Aviation. Schmude was the chief designer of the P-51, a German immigrant who had worked for Fokker and Messerschmitt before coming to the United States in the 1930s. Schmude understood aerodynamics better than almost anyone in the American aircraft industry. He knew that the key to long range wasn't just carrying more fuel, it was carrying fuel efficiently, minimizing drag, minimizing weight. Metal drop tanks, the standard design, were heavy and created significant drag. A 75-gallon metal tank weighed about 60 pounds empty. Add 75 gallons of fuel, 450 pounds, and you're adding 510 pounds per tank. 2 tanks, over 1,000 pounds. But what if the tank itself weighed almost nothing? Paper, laminated and treated with phenolic resin, could be formed into a rigid, fuel-tight shell. A 75-gallon paper tank weighed about 25 pounds empty, less than half the weight of a metal tank. The shape mattered, too. Schmude's team designed a streamlined teardrop shape that minimized drag. Wind tunnel tests showed that the paper tanks created 30% less drag than the standard metal tanks. And they were cheap. A metal tank required aluminum, skilled metalworkers, and precision tooling. A paper tank could be made in a factory that previously made cardboard boxes. The cost was about $15 per tank, compared to $50 for a metal tank. The Army Air Forces were skeptical. Paper for a fuel tank at 30,000 feet? at 400 mm, but North American built prototypes and tested them. The tanks held fuel without leaking. They withstood the low temperatures and low pressure at high altitude. They jettisoned cleanly. And most importantly, they worked. In November 1943, the first P-51Bs equipped with 75-gallon paper drop tanks arrived in England. The 354th Fighter Group, the first Mustang unit in the European theater, began flying escort missions. The results were immediate. On December 1, 1943, P-51s escorted bombers to Solingen, Germany, 475 miles from England. It was the deepest penetration by American fighters to date. The Mustangs engaged Bf-109s and Fw-190s over the target and shot down several without loss. But 475 miles wasn't enough. Berlin was 600 miles. The deepest targets, oil refineries in Poland and Czechoslovakia, were over 700 miles. North American went back to the drawing board. If 75-gallon tanks worked, what about bigger tanks? They designed a 108-gallon tank. Same paper construction, same teardrop shape, just larger. The tank weighed 35 pounds empty. With fuel, 680 pounds. Two tanks added 1,400 pounds to the aircraft, but the extra fuel more than compensated for the weight and drag. Wind tunnel tests and flight tests confirmed it. A P-51B with two 108-gallon drop tanks and full internal fuel could fly over 1,000 miles and return. That was enough to reach any target in Germany. But there was a catch. The fuel system. The P-51's internal fuel tanks fed directly into the engine through gravity and engine-driven pumps. Simple and reliable. But external tanks required a different system. The external tanks were mounted under the wings, below the fuselage fuel tanks. Fuel doesn't flow uphill. You need pumps. North American designed a system using engine vacuum to create suction, pulling fuel from the drop tanks into the fuselage tanks. It was simple, elegant, and required no electrical pumps or additional weight. But it had to be managed carefully. Pilots had to switch fuel selectors at the right time, use the drop tank fuel first, then switch to internal tanks. If you forgot and ran a drop tank dry while the engine was pulling from it, you could get air in the fuel lines. The engine would quit. At 30,000 feet over Germany, that was a death sentence. Training was critical. Pilots practiced the fuel management procedures until they could do it in their sleep. Check fuel gauges, switch to drop tanks, monitor fuel flow, switch back to internal tanks before the drop tanks run dry. Jettison empty tanks. It sounds simple, but in combat, with German fighters attacking, with flak bursting around you, with your wingman calling out bandits at 6 o'clock, it was easy to forget. Several pilots lost their engines over Germany because they mismanaged the fuel system. Some made it back, some didn't. But most pilots mastered it, and the results were extraordinary. On March 4, 1944, the 8th Air Force launched its first mission to Berlin. Over 700 bombers, escorted by P-51s with 108-gallon drop tanks. The Mustangs stayed with the bombers all the way to the target and back, a round trip of over 1,100 miles. The Luftwaffe rose to meet them. Over 100 German fighters engaged the formation. But this time, the bombers weren't alone. The Mustangs were there, and they tore into the German fighters. The P-51 was faster than the Bf-109G. It could outturn the Fw-190A. And critically, the German pilots knew that the Mustangs had been over Berlin. That meant they had fuel to fight. In previous battles, German pilots could sometimes avoid American escorts by waiting until they turned back. Not anymore. The 8th Air Force lost 69 bombers that day, a heavy toll, but far less than the losses on unescorted missions. The Mustangs shot down 82 German fighters. It was the beginning of the end for the Luftwaffe. Over the next 3 months, the Mustangs flew deeper and deeper into Germany. They escorted bombers to every target. The introduction of long-range drop tanks for the P-51 Mustang didn't just change tactics, it changed the entire strategic situation in Europe. Before March 1944, the Luftwaffe could concentrate its fighters near the most critical targets, deep inside Germany. They knew American escorts would turn back, and they could attack the bombers with impunity. The loss rates for the bombers were so high that some missions were called off or postponed. After March 1944, nowhere in Germany was safe. The Mustangs could reach any target, and they didn't just escort bombers, they hunted. General Jimmy Doolittle, who took command of the 8th Air Force in January 1944, changed the rules of engagement. Previously, escort fighters were ordered to stay close to the bombers. If German fighters didn't attack, the escorts didn't engage. Doolittle changed that. He told the fighter pilots, "Your job is to destroy the Luftwaffe, escort the bombers, but if you see German fighters, go after them, hunt them, shoot them down." The Mustang pilots took the order to heart. They began flying fighter sweeps ahead of the bomber formations, looking for German fighters before they could form up to attack. They strafed German airfields, destroying aircraft on the ground. They attacked trains and trucks, cutting off fuel and supplies. The Luftwaffe was being destroyed, not just in the air, but on the ground. The numbers tell the story. In January 1944, the Luftwaffe had approximately 1,600 single-engine fighters available for defense of Germany. By June 1944, that number had dropped to fewer than 500. Losses exceeded production. Experienced pilots were being killed faster than new pilots could be trained, and the new pilots were poorly trained. By mid-1944, a new Luftwaffe pilot might have 50 hours of flight training before being sent into combat. American pilots had 200 to 300 hours. The difference was deadly. German pilots called it der große Schlag, the great blow. Not a single battle, but a campaign of attrition that the Luftwaffe couldn't survive. Some of the most successful American aces of the war flew P-51s with drop tanks. Major George Preddy, 26 kills. Captain Don Gentile, 22 kills. Lieutenant Colonel John Meyer, 24 kills. These men and hundreds of others racked up kills over Germany because they had the range to hunt deep into enemy territory. But the impact went beyond air combat. The destruction of the Luftwaffe had strategic consequences. First, it enabled D-Day. The Allied invasion of Normandy required air superiority. If the Luftwaffe had been able to contest the skies over the beaches, the invasion might have failed. But by June 1944, the Luftwaffe was a shadow of its former self. On D-Day, German fighters barely appeared. The Allies landed 150,000 troops with minimal interference from the air. Second, it crippled German industry. With the Luftwaffe unable to defend German airspace, American and British bombers could strike targets with increasing accuracy and impunity. Oil refineries were destroyed, cutting off fuel for tanks and aircraft. Ball-bearing factories were hit, disrupting production of everything from aircraft engines to tank transmissions. Transportation networks were shattered, making it impossible to move supplies to the front. By late 1944, Germany was running out of fuel. Luftwaffe fighters sat on airfields, unable to fly because there was no aviation fuel. Panzer divisions were immobilized. The vaunted German war machine was grinding to a halt, not because of lack of equipment, but because of lack of fuel. Third, it forced Germany to divert resources. To defend against the bomber offensive, Germany had to pull fighters and anti-aircraft guns from the Eastern Front. This weakened German defenses against the Soviet advance. Some historians argue that the strategic bombing campaign, by forcing Germany to fight a two-front air war, shortened the war by months or even years. And all of this was made possible in large part by a paper fuel tank. But let's be clear, the drop tanks weren't the only factor. The P-51 itself was an exceptional aircraft. The Packard Merlin engine was a masterpiece of engineering. The pilots were skilled and brave. The ground crews kept the aircraft flying under difficult conditions. The intelligence officers provided targeting information. The logistics network supplied fuel, ammunition, and spare parts. War is a system. No single innovation wins a war. But some innovations are more critical than others, and the drop tank was one of them. Consider the counter. The story of the P-51 drop tank isn't just about engineering. It's about the people who made it work. Start with the engineers at North American Aviation. Edgar Schmude and his team worked under immense pressure. The Army Air Forces needed a solution, and they needed it fast. There was no time for lengthy development programs or extensive testing. Design it, build it, test it, produce it. Months, not years. The engineers worked 12-hour days, 7 days a week. They ran wind tunnel tests, built prototypes, tested them in flight. When something didn't work, they redesigned it overnight and tested again the next day. Schmude later said that the P-51 program was the most intense period of his career. "We knew that men's lives depended on what we did," he said in a post-war interview. "Every day we didn't have a solution, more bombers were being shot down. That was a heavy weight to carry." Then there were the production workers. The paper drop tanks were manufactured by companies that had never built aircraft components before. Cardboard box factories, paper mills, furniture manufacturers. They were given blueprints and told to produce thousands of tanks per month. The workers, many of them women, learned new skills. They operated presses that formed the laminated paper into shape. They applied resin coatings. They installed fuel fittings and release mechanisms. They inspected each tank to ensure it met specifications. It was repetitive, unglamorous work, but they knew it mattered. Posters in the factories reminded them, "Your work saves lives," and it did. Then there were the ground crews in England, the men who maintained the P-51s, who installed the drop tanks before each mission, who checked the fuel systems, who ensured everything worked. These men worked outdoors, in all weather. English winters are cold and wet. The airfields were muddy. The work was hard, physical labor, lifting tanks, connecting fuel lines, checking fittings. And they did it under pressure. Missions launched early in the morning. The aircraft had to be ready. If a tank wasn't installed correctly, if a fuel line leaked, if a release mechanism jammed, a pilot could die. The ground crews knew that. They took pride in their work. One ground crew chief, interviewed years later, said, "We never met most of the pilots. They'd climb into the cockpit, we'd pull the chocks, and they'd taxi out. But we knew their names, we knew their aircraft, and we made damn sure those tanks were perfect." That was our job. And finally, the pilots. The men who flew the P-51s deep into Germany, who managed the fuel systems, who fought the Luftwaffe, who brought the bombers home. Flying a P-51 with drop tanks required skill and the P-51 Mustang is remembered as one of the greatest fighter aircraft of World War II. Fast, maneuverable, beautiful. It's an icon. But the Mustang's greatness wasn't just the airframe or the engine. It was the system. The combination of aircraft, engine, fuel tanks, tactics, training, and logistics that made it effective. The drop tank was a critical part of that system. Without it, the P-51 would have been just another short-range fighter, effective in a limited role, but not a war winner. With the drop tank, the P-51 became the weapon that broke the Luftwaffe and enabled the strategic bombing campaign that crippled German industry. The lessons from the drop tank program are still relevant today. First, innovation doesn't have to be complicated. The paper drop tank wasn't a technological marvel, it was a simple idea. Executed well, pressed paper, resin, a streamlined shape. Nothing exotic, nothing that required years of research, but it solved a critical problem. Sometimes the best solutions are the simplest ones. Second, speed matters. North American didn't spend years developing the drop tank. They designed it, tested it, and put it into production in a matter of months. In war, time is a resource as valuable as steel or fuel. The side that innovates faster has an advantage. Third, logistics and production matter as much as design. The paper drop tank was effective not just because it worked, but because it could be produced in massive quantities, cheaply and quickly. A brilliant design that can't be manufactured at scale is useless. The Allies won World War II in part because they outproduced the Axis. American factories built 300,000 aircraft during the war. Germany built about 120,000. The Soviet Union built about 160,000. The Allies had more of everything: more aircraft, more tanks, more ships, more fuel, more ammunition. But quantity alone doesn't win wars. You need quality too. The P-51 with drop tanks was both. High-quality aircraft produced in large numbers with a simple, effective solution to a critical problem. After World War II, the drop tank became standard equipment on fighter aircraft. The F-86 Sabre in Korea used drop tanks. The F-4 Phantom in Vietnam used drop tanks. Modern fighters like the F-16 and F-18 use drop tanks. The materials have changed. Modern drop tanks are made of aluminum or composite materials, not paper, but the concept is the same. Carry extra fuel externally, jettison it when you don't need it. Extend your range without compromising performance. The P-51 proved the concept. Every long-range fighter since owes a debt to the engineers at North American Aviation who designed the first practical drop tank system. The P-51 itself had a long career. After World War II, Mustangs served in the air forces of over 50 countries. They flew in Korea, where they were used primarily for ground attack. They flew in smaller conflicts in Central America, Africa, and Asia. The last military P-51s were retired in the 1980s, but many still fly today, owned by private collectors and warbird organizations. At air shows around the world, you can see P-51s perform. The sound of the Packard Merlin engine, the sleek lines, the speed and grace, they still captivate audiences. If you ever get a chance to see a P-51 fly, take it. It's a piece of history, still alive. Several organizations maintain flying P-51s. The Commemorative Air Force has several. The Collings Foundation operates a P-51 that gives rides to the public. The Old Flying Machine Company in England operates Mustangs at air shows. These aircraft are maintained by volunteers and professional mechanics who keep them airworthy. It's expensive and time-consuming work. Parts are hard to find. Engines require constant maintenance. But the people who do this work believe it's important. They're preserving history. They're honoring the men who flew these aircraft in combat. One P-51 owner, interviewed at an air show, said, "When I fly this aircraft, I think about the pilots who flew it in the war. Some of them didn't come home."